Hi viewers, this is Sri Ramlu. So before watching this video, please subscribe, like it, share it, and don't forget sharing this video to your friends also. So now P-type semiconductor. So I explained N-type semiconductor. Now P-type semiconductor. When a small amount of trivalent impurity is added to a pure crystal during the crystal growth, the resulting crystal is called as p-type extrinsic semiconductor, or simply we can say p-type semiconductor. What is here? When a small amount of trivalent impurity, small amount of tri stands for 3, okay, trivalent impurity is added to pure crystal. So pure crystal, pure means not anything added, only that contains single element, that is a pure crystal. During crystal growth means during the crystal preparation, the resulting crystal what we call p types extrinsic semiconductor. Okay, so when we add the small amount of trivalent to the pure crystal, when crystal is preparing, then such a crystal is called p type. Why it is p type called, that is also explained inside lesson. Consider the case when trivalent boron. Here boron I have taken. Why it is the boron is taken? If you observe the periodic table, in the periodic table, third group, first element is boron. Okay, third group, how can we decide it is belongs to third group? Its valency is third. 3 are valency electrons, valency electrons 3 present, so that is what is the third group element. Each atom of boron fits in the germanium crystal with the only 3 valent bonds. Only 3 valent. This because the 3 valency electrons of boron atom forms covalent bond with the valency electrons of germanium atom. Right? That boron atom, what it can do? It can forms covalent bond with the germanium atoms. Okay, so germanium atom present all side. Okay, so like this it form bonds, like this it forms bond, means covalent bond, that is. In the fourth covalent bond, only germanium atom contribute one electron, and there is a deficiency of one electron, which is called as hole. Deficiency means no electrons present. Okay, around the boron. Now see the diagram. This is the diagram. Now it is a boron containing only 3 valency electrons, like this. So this electron forms a bonds, covalent bond with the germanium atom of this electron, and with this electron, and with this electron. Suppose this electron want to form a bond, then here also one electron has to present, but no electron present this side. Why? Because only 3 electron it has. So that is why here there is a one vacancy. This vacancy, what we call, this vacancy we call hole having a charge positive, so positive. So that is why this material is called p type. Positive stands for p type. P stands for positive. Okay, now yes, it is over. In this way, each one boron atom is generate one hole. Each boron atom can give one hole, means it produce one hole. When a small amount of boron provides millions of holes, it gives. One boron can give one hole. Then if you add the small amount, means it contains millions of borons. So like this, millions of holes will be produced. Now the energy band description of p-type semiconductor is shown in figure. Energy bands. Now see here energy band. In the last video, in n-type video, energy, in the energy band, if you observe there in conduction band, large number of electrons are shown. Why? Because that is n-type, and a less number of holes are shown in valency band. But it is a p-type, so that is why more number of holes present in valency band, less number of electron present in conduction band. In what type? In p type. Why it is a, this is a p type? video. This is the energy band description. Okay, next, energy band description of p type is shown. Yes, the addition of trivalent impurity produces a large number of holes in the valency band. Yes, large number of holes will be produced. So all the holes we have to show in valency band only, we should not show them in conduction band. There are a few conduction band electrons due to thermal energy associated with the room temperature. So thermal energy associated with the room temperature means at a room temperature electrons, extra electrons will be produced. Those electrons are shown in conduction band. Only a few electrons are shown. Just now I have shown you. In the incomplete covalent bond, remaining fourth electrons of germanium atom also tries to form a covalent bond. Here, if you observe once again, check it. Here it is a vacancy. Okay, then what happens? This electron can combine with this hole. Then what happens? This hole disappear. But here what happens? Here vacancy will produce. So that means here holes will produce. So at the beginning, holes was here. Okay, na? At the beginning, holes was here, and after coming this electron from here to here, here holes will produce. That means we can say when electron is moving in this direction, opposite to it, electrons holes will transfer. Okay, and next later what happens? Later this hole will be this hole will be covered or recombined with this electron, then here hole will create. So that means hole is slowly it is moving in this direction and in this direction. So like this whole direction we can show. Okay, so in the incomplete covalent bond, remaining fourth electron of a germanium atom also tries to form a covalent bond. So just now I said you, it steals an electron from the neighboring germanium atom. So already boron atom has one hole. That hole, to fill this hole, this boron atom can steal one electron from the neighboring germanium atom and it will be filled, and here hole will be created. Okay. Due to this stealing action, a hole is created and in adjacent atom. So like this, in adjacent atom, beside atom, what happens? One hole will create. This process continues and hole move about in random way due to the thermal effect. So like this, just now I shown in the diagram, hole just where the beginning here it was here, and later it is moved like this, and later it is moved like this. I have shown in the diagram. So in the same manner, hole cannot move always in one direction. It moves in random directions. Okay. Impurity atom that contributes hole in this manner are termed as acceptor. Alright. Here impurity atom like a boron, what they give, they produce one electron, one hole, and that hole will attract the electrons. Okay. So will attract means accept the electron. So that is why they are called acceptors. Okay, impurity atoms that contributes holes in this manner are termed as acceptor because they accept one electron from germanium atom. Next, since current carriers are positively charged particles means here current is because of holes only. This type of semiconductor is called a p-type semiconductor. Why it is a positively charged particle? Positive means p, so that is a p-type semiconductor. Okay friends, don't forget subscribing this video.